All right, welcome back to College Algebra. We are going to do an example of how to turn a standard form parabola, standard form quadratic, into a vertex form quadratic. All right, so here we go. So we're going to do a different example. So we're going to look at y is equal to -1/4 x squared plus 2x minus 2. And what we have here, again, if you're looking at this and like, oh, this is going to be really a mess. Like if you're students in my class right now for college algebra, your homework problem does not include problems that are this difficult, but your book does include this is the example. So we're just going to walk through it and understand that as you're doing your homework, you're probably not going to need all of these steps. All right. I apologize for the fact that it's going to do that. However, this does give me a chance to like show all the different things that you could do. Okay. So what we have here is step one. All right, where the instructions here are convert to vertex form. Okay, to do that, we're going to have to complete the square. Okay, now to complete the square, okay, step one, we're going to put into the correct form. Okay, we're going to put into the starting form. All right, so what that means is we have to factor out a -1/4, all right, from the first two terms. So we have an x squared here. Now, -1/4 times what would be 2? And I'm going to guess -8. Right? So -1/4 times 8, negative times negative is positive, 8/4 is in fact 2. And we're just going to separate that out. Okay. Next deal is we are going to go ahead and identify our middle term. Okay, and this is where the magic of the complete the square happens. Okay, we get the middle term is -8. Take this thing over 2 is -4, and then we're going to square it. All right. So our step 2 is we identified the middle term. Step 3 is we're going to add and subtract. So this is step 3. We're going to add and subtract 16 inside the parentheses. Okay, so here we go, right? Here we go. We have -1/4. We have x squared minus 8x. And then we're going to add a 16. We're going to subtract the 16. And we're just going to have this -2 hanging out. Don't forget about this. All right, that's an easy way to get, the wrong answer real fast. Okay, it's not the biggest mistake in the world that students make, but it does bring you from an A to a B, or if you had a B, it takes you from a B to a C, and that's the kind of mistake it does. Okay, it drops you like a grade. Okay, I don't think it would drop you from a D to an F, but once you're in the D range, All right, so we're going to group these up. Okay, we're going to have, so step 4, right? Step 4 is actually complete the square. Right, we're factoring. So we have -1/4. Could you factor x squared minus 8x plus 16? I know you can. X minus 4. Look at that. There's a -4 right there with my b over 2. It's the same -4 as this one is. All right. And then we've got a -16 sitting here, -2. Okay. Now we have to distribute. Okay. Now we're going to go ahead and distribute. So this -4 gets to visit both of these pieces. Don't forget the second one. Don't do the third one, right? That's why we have the brackets. That this one is not affected by the -1/4. But don't forget this one. Students get really excited, like, "Yay, I did it!" And then they forget. We have -1/4 x minus 4 squared. -1/4 times -16. Isn't that a positive 4 minus 2? Okay, so it works out like this, almost like somebody got out of a textbook or something, right? And now we have, right, this is our vertex, this is our quadratic in vertex form. Right? If we were back in the section where we had to do translations, you would look at this and say, oh, look at, excuse me, look at this. We have a translation. We have a 4 to the right. Right? We have a two vertical up, right? Two up, right? We have a vertical flip. Flip around the x-axis, and then we have a compression of a quarter. Okay, so we could, if this was in the previous section, I handed you this to graph it. There's a lot of elements going on here. When I say technically you wouldn't have a problem, I know that last chapter this would have been a tough problem because there's a lot going on. Okay, so what's our vertex? Right? Now remember the formula for the vertex, right? It's y is equal to ax minus h squared plus k. This negative sign belongs to the formula. It does not belong to the 4. So the vertex is just going to be 4, and then we have 2. All right? So my vertex is 4, 2. And now we can start asking some other questions. All right? So let's see here. What if we want the x-intercepts? Okay. Y-intercept is nice. X-intercept is easier said than done. All right. So we have negative 1 over 4, x minus 4 squared plus 2, and the x-intercepts were y is equal to 0. So we're going to set it equal to y. We're going to set it equal to 0. Okay. And now we're going to solve for x. So again, we go into multiplication and division, so PMD, and then AS. This goes in reverse order, right? When we're calculating, it goes in this order. When we're solving, it goes in that order. So let's go ahead and get rid of the addition subtraction. So it's negative a quarter. X minus 4 squared is equal to negative 2. We're going to multiply both sides by negative 4. Right, that'll undo this. So we end up with x minus 4 squared is equal to negative 2 times negative 4 is 8. Okay. And then what we're going to do is we're going to employ square root principle. Okay, so we need square root principle here. All that means is take the square root of both sides. Okay. X minus 4 is equal to plus or minus square root of 8. All right, now we can simplify this because 8 is equal to 4 times 2. And it might be equal to other things, but I think 8 is like, this is pretty much it. One of these is a perfect square. So we could say that square root of 8 is equal to the square root of 4 times the square root of 2. Right? Be careful when you get to complex numbers. You can't quite do this. Okay, weird things happen. But with real numbers, you are allowed to do this. All right. So square root of 4, that's 2. And we're just going to leave the square root of 2 alone. Okay. So we have x minus 4 is equal to plus or minus 2 root 2. And then all we're going to do is we're going to add 4 to both sides because now we're inside the parentheses. We have 4 plus or minus 2 root 2. Okay. So my x-intercepts, x is equal to 4 plus root 2, or 2 root 2 rather. X plus 2 root 2, and x equals 4 minus 2 root 2. Okay. The point I'm going to use, the points, four plus 2 root 2. What's y? Put parentheses here because it's a point, 4 minus 2 root 2. Well, if you remember when we started this whole business, y was 0. So yeah, that was the whole point of that. Okay, so the points 2 plus 2 root 2 and 2 minus root 2. And did I go through and these are, if they ever ask you for what's the exact value, this is what they mean by exact. Okay, they don't mean anything else. Now the graph, I'm going to say, like, I did, again, I went through and did this a little bit before. 1.17, okay, so 6.83-ish, 1.17-ish, right? And then what's the y-intercept? Well, y just had a turn at being 0, so now it's x's turn to be 0. So we're going to set x equal to 0. So again, we could use either form, right? What did we start with here? We started way up at the top here with this guy right here, -1/4 x squared plus 2x minus 2. -1/4 x squared minus 2x minus 2, right, equals y. And then we also had, right, we could also write down -1/4 x minus, what was that? X minus 4 squared minus 2, right? Just double checking to make sure I got that first one correct. All right, -1/4 plus 2x minus 2. All right, and this is y. So we have to set x equal to 0. It's your choice. Which one do you want to do this to? Right, where do you want to set x equal to 0? They will both come out the same. This one, right, if I say this is 0, this is 0, okay, -2. Here we have 0 minus 4 squared, so that's going to be 16 times -4, right? -1/4 times that, which is -4. Oh, sorry, positive, right? Because we squared it, positive. Oh, no, that's not right. It should come out to be the same. 16, 4, was that a +2 here? Let's call, oh, what is a +2? Look at that. This one was a plus. This one was minus. This one's a plus. -4 plus 2 is -2. Okay, so either way, set x equal to 0, y is equal to -2. Your choice on how you want to do it. Right? And I think after that, they're going to ask us to graph it. So graph the function. Okay, my vertex, right, is going to be, my vertex is going to be 4, -2, right? 4, 2, rather, 4, 2. So that's in the first quadrant, right? So we can do something clever like this. 1, 2, 3, 4, 5, 6, 7. 1, 2. 1, 2, 3, 4. 1, 2. Right? And then what was our intercepts? Our intercepts were 6.83. So here's almost 7. And what are we up to? 1.17. So somewhere between 1 and 2, but closer to 1 there. My y-intercept was y equals -2. So maybe we'll come down a little bit. So I wish I was more clever, but there it is. And then we can go ahead and graph this, okay? Pretend this goes through the dot, all right? All right, so there we go. There's our graph, all right? Very pretty. They're gonna ask a bunch of stuff that we already know. What's the axis of symmetry? Well, we know the axis of symmetry goes through the vertex. Right? Wasn't that the line x equals 4? Right? Does this function have a maximum or a minimum? Well, gee, I think it has a maximum. Maximum, and we are at, right, 4, 2. Right? The maximum is value 4, 2. What's the domain? What's the range? Again, the domain, this is a trick question. We have a polynomial. It's all the reals. All right, that's just the way that works. There's no places where we have an asymptote or where, we're taking a square root of a negative number or anything like that. It's just everything. Okay, every number I put in will be just fine. Some word problems will have like time has to be greater than 0. Like, great. T is, we'll have 0 to infinity, whatever. Range, well, it looks like we can go down as far as we want here. So -infinity, and it goes up to 2. Okay. We always use a parentheses for negative infinity, because if you put a bracket there, that means that you got there, and infinity isn't really a number, it's a concept. So we don't say that we got to negative infinity, we just say we're headed there. Okay. So but yeah, those are all the different pieces they could ask us on a problem that was probably way too hard and had way too many steps. Um, but we'll do some homework that's more representative of your homework. We'll do some problems, examples that are more representative of your homework in the next video, and I'll take you through some of those. All right, so this is the whole picture. You probably will not have to do everything that we did in this example, but if you ever have to come back and do something like this, here you go. All right, so I'll come back and do a couple of examples from the book, and we'll keep going with that. All right, thank you.